Okay, so here we'll talk about the circulating charge particles. So here it actually mentioned that if a moving charge enter a uniform B field, okay, it will be have circular motion. It will have a circular motion. And the condition is actually the velocity. If the velocity is perpendicular to the B field, then there will be a circular motion. And the circular motion, of course, we need to find the radius of the circle. Okay, so according to high school physics, if you should know that F equals mv squared over r. Okay, something like this. So actually, this F is actually comes from the Lorentz force. Okay, so this is actually Q times V times B equals mv squared over r. So in this case, we can slightly cancel this V with this V squared. So finally, we have R to be mv over QB. Okay, so this will be the radius of the circular motion. Okay, so actually this m should be a constant given a specific particle, and this q is also a constant given a specific particle. So this ratio is a constant. So the remaining condition that is related to the radius is first one, the initial velocity of the charge, okay, and also the B field. Okay, if V is larger, okay, so this R is proportional to the velocity, and this R is inversely proportional to the B field. Okay, so we will use this slightly later in this chapter to explain the mechanism of the particle accelerator. Okay, so here we have a sample problem first. Okay, so it says an electron with a kinetic energy of 22.5 eV move into a region of uniform magnetic field or B field of magnitude this one. The angle between the direction of B and the electron's velocity is 65.6 degrees. Okay, they are not perpendicular to each other. So which means that this is V, this is the velocity of the electron, and then this is the B field, okay, with 65 degrees. So this is 65 degrees. Okay, so in such a way, what is the pitch of the helical path taken by electron? Okay, 所以它的轨迹是一个 helical path， 它就是一个螺旋的一个轨迹。因为如果刚才这个情况，如果这个 V 跟 B 垂直的话，那就只有这个平面上面有那个 FB 作为向心力。那但是在这个情况的话，就是你把这个力分成V parallel 跟 V perpendicular， 那就是这个力会造成它圆周运动。你先忽略掉这个，那只考虑这个速度或者这个 velocity， 这个速度啦，这个速度或者是速率嘛，考虑这个速度跟这个 B field 的话，它就会圆周运动。那但是我们有这个方向的 V parallel， 那就会让它在任何时刻都是在往上在动，所以最终它就会形成一个螺旋形的一个轨迹。你如果全部都投影在一个平面上面，它就是一个圆形。它就是因为这个 V parallel V perpendicular 跟这个 B 所产生那个 Lorentz force 而来的，但是多了这个 V parallel 的话，它就会让它一直往 z 方向去动 ，OK。所以他就问你 ，What is the pitch of the helix path？Pitch 的意思是，它会绕着那个螺旋形转嘛，所以它在同一个圆，就是比如说你投影，它在同一个点的时候，相邻两个的同一个点，它如果投影在那个平面，它会圆形嘛，它在这两个点，如果投影到同一个点。然后也是相邻的那个螺旋形的话，那这个距离我们就叫做 pitch， 就是一个螺旋的一个间隔的意思。Okay, so yeah, so first of all, we try to find the velocity first. Okay, so v equals 2k over m, which is 2 times this one, 22.5 times 1.6 times 10 to minus 19. And then all over, it is actually an electron, right? An electron. Okay, so this is 9.11 times 10 to negative 31. Okay, so the velocity is actually 2.81 times 10 to the 6th power meter per second. Okay, and then for the pitch will be like P equals V parallel times T. T is the period of the circular motion, 就是转一圈的那个周期周期。So V parallel will be V times cosine of phi. Cosine of phi. V parallel is actually this one. Okay. So this is a right angle triangle. So V times cosine of phi will be V parallel. And then times, okay, so what is T? Just now we know that R equals mv over qb. Okay, we know R equals mv over qb. mv over qb. Okay, so actually the period will be like 2 pi r over v. 2 pi r over v. Okay, so we will have 2 pi mv over qb all over v. So this v and v cancel. So finally we have 2 pi m over qb. Okay, so this is the period of the circular motion. Okay, so this is 2 pi m over qb. Okay, so here v equals 2.81 times 10 to the 6th power cosine 65.5 degree. Okay, so this is the v parallel. And then we have 2 pi m is 9.11 times 10 to negative 31. And then over 1.6 times 10 to minus 19. And then b is 4.55 times 10 to negative 4th power. Okay, something like this. Okay, so this number is 9.16 centimeter. 9.16 centimeter. Okay, for this one we also calculate the velocity from the kinetic energy, but actually we need to know that how to define the pitch. The pitch is actually the same point on the helix line, and then for the adjacent locus, and so this is pretty much it. What we need to do is we need to distinguish. Okay, this is the V parallel. Okay, V parallel and B won't have any Lorentz force because they parallel to each other. So this one will generate Lorentz force. So this one related to the to the circular motion. Yeah, but this one related to this z-axis, the z-axis displacement. Okay, so this v parallel is actually related to the pitch. Okay, of course, this v parallel multiplied by the pure width will be the pitch. Okay, so here we have another one. So it says the essential of a mass spectrometer, okay, which can be used to measure the mass of an ion. An ion of mass to be measured. Okay, so 我们要测这个离子的质量嘛。The charge Q is produced in source S, and the initially stationary ion is accelerated by the electric field due to the potential difference V. OK， 所以它的意思是 OK， 这里有一个 source 啊，这里有一个 source， 那这里有个 battery， 那这里就会从这个底部到这个 source 就会有一个 potential difference， 那有个 potential difference 就会有电场往上的，那这个是正 Q， 所以它就会加速到这个点，那就会从静止到这边有一个起始的速度进入这个均匀的 B field， OK， 大概是这个意思。So the initial stationary ion is accelerated by the electric field due to the potential difference V, and the ion leaves S and enters a separate chamber, in which a uniform B field is perpendicular to the path of the ion. OK， 所以这个 B field 是 pointing out of the page. A Y detector lies on the bottom wall of the chamber and cause the ion to move in a semicircle and thus strike the detector. OK， 那这个是均匀电场跟它速度垂直嘛，所以进入的话就会有一个所谓的那个circular motion 嘛，就是圆周运动嘛。那圆周运动因为它这边有个板呢，所以打到这边就会停下来，那它就会知道说这个打到这个板的位置是什么，那我就知道这个 x 是什么。那透过这个 x 的话，我就知道这个v 是什么之类的。OK， 然后 suppose that a b, v and a q and strike the detector at the point lie at x. Okay, so we know the value of x. What is the mass m of the individual ions at atomic mass unit? OK， 就是用一个原子的质量单位，就是一个质子的重量。Okay, so yeah, so here we can make use of the conservation of energy. Delta K plus delta U equals 0. Okay, so at the very beginning, okay, there is no velocity. So K initial is 0. And then finally, we have some kinetic energy, some velocity. So we have 1/2 of mv squared plus U, delta U. Delta U is actually the potential difference here. So we have a negative Q, QV, okay, negative QV. Okay, we don't know what charge it is. Okay, actually we only know that it is a positive charge. Okay, so in such a way we know that V equals 2Q capital V over M, and then take the square root of the whole thing. Okay, so first of all we know this one. Okay, maybe I just put it here. V equals square root of 2QV over M. Okay, next we know R equals MV over QB. MV over QB. Okay, so we can just put this V into here. So we have M over QB, and then we have this square root of 2QV over M. Okay, so actually we can just put this M inside and then put this Q inside, because we actually have this Q, and this is M and M, so it can be partly cancelled. So finally it becomes 1 over B and then square root of 2 MV over Q. Okay, so it's just some algebraic calculation. And here it is actually the diameter. It is actually the diameter, and this is the radius. So actually we have x equals 2r, so which will be 2 over b times square root of 2mv over q. Okay, so this is the x, the expression of x. And finally, what we need to find is the mass, Mr. Mass. So we try to move all the other things to one side and then find the expression of m. Okay, so actually it is something like hv, and then here we have a x squared, and then b squared q. Okay, so you can just square both sides first. X squared equals 8, and then mv, and then we have a b squared q, something like this. Okay, and then we just keep m on one side, so we have 8v here, and then we have b squared q on the right side, and then we also have x squared. Okay, then we can just plug in all the numbers. Okay, so x is 1.6254 squared, and then b is 80 times 10 to the negative third, and then square, and then times q is 1.6 times 6022 times 10 to minus 9, and then over a times v. What is v? 1000 volt. Okay, so this is 3.3863 times 10 to negative 25th kilogram. And then if you use this one to divide it by this 1U, which is 1.6605 times 10 to minus 27, it becomes 203.93 U. Okay, so roughly 204 U. Okay, slightly less than 204 U. Okay. Okay, so here we will introduce two types of the particle accelerator. The first one is called the cyclotron. Cyclotron in Chinese is called 回旋加速器 回旋加速器 Okay, yeah, so there are quite a lot of texts, but yeah, I don't think we need to go through it. So let me try to explain it. Like this. Okay, so you can see the figure is somehow like this. There is a D shape on the left side and D shape on the right side. So in the blue area, we will generate some B field pointing out of the page, as shown in the green dot. Okay, so all these are B field. And between these two D shape, we have a small gap in between. Okay, this small gap, we don't have any B field. But in that case, we will try to generate some alternating E field. So the idea is somehow like this. So first of all, at the center point S, let's say here, yeah. So at the very beginning, it tried to enter. Okay, so you can consider this is 2D shape. something like this, something like this, or maybe I draw it slightly larger. Okay, maybe I draw it like this. Okay, you can see the D shape. Okay, so we have a 2D shape here, and then okay, S is here. So it try to generate a particle. Okay, let's say moving to the left side. Okay, so maybe at first it try to suppose it is so we may assume it is positive charge or negative. So if it is a positive charge, then in that case at the very beginning we try to generate E field pointing to the left side. So a positive charge will accelerate to the left side. So it will have a velocity, let's say v, when it enter the left D shape. Okay, so inside this D shape there is B field pointing out of the page, B field pointing out of the page. So in such a way, there is no E field anymore, but the B field, but the perpendicular B field. So in such a way, it will have a circular motion. It will have circular motion, and then going back to this point. And at this time, we try to alternating the E field. Let's make the E field pointing to the right side. So in such a way, this particle will start to accelerate. Okay, so up to this point, this is V. This is V. This is V because it is a circular motion. The velocity doesn't. The magnitude of the velocity doesn't change. The only change is the direction. Okay, is the direction, but the speed doesn't change at all during the circular motion. But here, after leaving the left D shape, okay, so we have an E field pointing to the right side. So to make this particle accelerate up to this part, and okay, so here we will have a perpendicular B field again, and then it will have circular motion. So in that case, this V prime is larger than V. Okay, so V is larger, M doesn't change, Q doesn't change, B doesn't change. So in such a way, this radius will be larger. So it becomes something like this. Okay, going to this part. So this is V prime again. And then at this part, okay, we try to alternating the E field again. Okay, make it pointing to the left side. So this particle will point to the left side. So there will be an acceleration pointing to the left side again. So it becomes V double prime. And then it will have another circular motion with even larger radius, V double prime, so on and so forth, until it reaches the radius of the disk. Then it cannot be further accelerate. Okay， 那大概就是这个原理，大概就是这个原理。那所以 ，so actually we need to control the frequency for alternating the E field, which is actually this FOSC. So it should follow this one. So it's somehow like 2 pi m QB. So it's somehow like the T 1 over T. Just now F oscillate should be 1 over T. T is 2 pi V, 2 pi R over V, which is we have just calculate that term just now. So we have a QB over 2 pi m as this F oscillation. Okay, so the limitation for the synchrotron is that it cannot generate too high energy. The energy should be less than 50 mega eV. The reason is that we actually need to generate the B field in a large area, actually for a whole circle. Of course, we have a gap in between, but actually this 2D shape is can actually form a whole circle. And if we need to generate B field in a whole circle, and of course, if we want this energy to be larger, okay, the energy means kinetic energy. Kinetic energy is actually 1/2 mv squared. So m is a constant. So if we want this energy as large as possible, which means that we want this velocity to be as large as possible. So if we want this v to be as large as possible, in such a way, we need to either increase the radius of the disk or the radius of the circular motion, or we actually need to increase the B field. But generating B field in a very large area will be very power consuming. So this is the limitation for the synchrotron. Okay. So actually there is something called a proton synchrotron. Okay, and actually the beam is injected into a proton synchrotron booster. Okay, 就是说这个是原子的这个同步加速器啊，原子的同步加速器。那原子的同步加速器，它在进这个同步加速器之前，它要先有一个同步加速器的一个增强的一个它就是你要把它加速得很快，那你就要先有一个相对比较快的速度进去，不然的话进去以后它就会死掉之类的。Okay. Okay. So actually, the beam is actually into the PSB, so which accelerate the proton to 1.4 GeV. OK. 所以它就是这个 PSB 就是先把这个质子加速到1.4个 GeV， 就是这个是另外一种 synchrotron， 这个叫做同步加速器，同步。就是另外一种的，就是先暖机一下然后再进去然后你就看到这个1.4G 已经远比这个50 mega 大得多然后 follow by 的proton synchrotron 才真正进入到这个质子的同步加速器，然后最后把它推到25 GeV。你可以想象，就是现在有一个跑得很快的那个跑步机，现在要你马上它开得很快，然后你马上什么都没有跑，你就跳上去，那你就会跌倒，所以你必须要先有一个相对比较高的速度，你再上去，你才跑得起来，或者是你上去那个跑步机，你慢慢加速，你要慢慢加速，所以这个 PSB 就是类似这个概念那有兴趣的话可以去看一下那个。Wikipedia， 那它的那个形状大概是这样的，它就只剩下一个圈圈，所以我们就不需要在整个圆的范围都产生 B field， 我们只需要在这个环的范围产生 B field， 但是这个的控制就会比较复杂，就是我们要产生一些。大小一直在改变，方向一直在改变的磁场，我们才能够把这个加速的那个粒子确保在这个怎么说？在这个环里面动，因为它一碰到 B 的话，它就会减速嘛；一撞墙的话，它当然就是弹回来就会减速嘛。所以你要准确的控制它，让它慢慢加速，然后维持在这个环的范围，然后这个。B field 可能也会一直增大的，所以它才会就比较省电，然后也能够加速到一个比较高的能量。但你可能会问，那这些粒子加速器有什么用处啊？这粒子加速器的用处的话，其实是那些物理学家其实在怎么说，就是在找一些所谓的基本的粒子基本的粒子，就是21章的时候曾经稍微提过一下的基本粒子。那高中的化学的时候，可能老师就跟你说我们先有元素嘛，那元素再拆开的话，可以有什么电子、有质子、有中子。 那电子、质子、中子，它能不能再变成更小的粒子呢？电子的话，目前来说是不行的。那质子、中子的话，就是可以，是可以。那用什么方式去把它拆散呢？就是说，我们把它加速到很快，然后让它们碰撞。那碰撞的时候，看它会不会因为碰撞而散开，就是大概是这个概念。它如果能够散开的话，我们就看散开之后就会形成这个我们目前比如说叫做 quark 的东西，就是之前有提过嘛，就是比如说质子的话，2个 up 1个 down 组成一个质子，或者是1个 up 2个 down 组成一个中子。那这个是第一轴第一组第一个 generation 第一代的，应该是说第一代的。那这边的能量相对比较小，2.2个 MeV4.7个 MeV 就能够产生出来。那有第二代的能量比较高，1.28 G 个 eV per c square，96 mega eV per c square。那就需要比较高的能量才能够产生出这个 chime 跟 strange 然后这个 top 跟 bottom 的话，又要更高的能量，就是173跟4.18 G 个 eV per c square 才能够产生出第三代。你说有没有第四代？如果那个加速器可以到更高的速度的话，也许可能会发现，但是目前还没有，就是目前只看到1、2、3代。那电子的话，还在这个基本粒子这个表里面，所以就是代表说这个粒子它是一个氢子 ，lepton 是氢子氢子这个叫夸克这个夸克有这个电子什么的，电中子 ，OK， 然后苗子 ，OK， 涛子什么的。然后还有一些叫做玻色子玻色子，这个就是所谓的 Higgs boson， 就是这个什么上帝粒子，就前几年发现的那个 Higgs boson。那 Higgs boson 的话就是比较特殊的，它就是一种赋予其他粒子质量的一个粒子来的，就是对，就是所以它叫做上帝粒子，就是说它分派一些能量给别人。OK， 这是题外话讲了。那回到这边。Okay, so here let's take a look at the sample problem. So it says suppose a cyclotron is operate at an oscillating frequency of 12 megahertz and has a d radius r equals 53 centimeter. What is the magnitude of the B field needed for the deuteratron? Okay, deuteratron. One proton and one neutron to be accelerate in the cyclotron. The deuteratron mass is roughly 2 times of the proton. Okay, so here it asks you what is the magnitude of the B field. What is the magnitude of the B field? So actually we can use this one. F equals QB over 2 pi m, but actually we want to find B. So actually we put B on one side and then we move all this thing to the right side, to the other side. So we have B equals 2 pi m F oscillate and then over Q, something like this. And then we have 2 pi times 3 times 3, 4 times 10 to negative 27. And then times 12 times 10 to the 6th power all over. Okay, this is one proton, one neutron. Neutron is an electrically neutral, so the charge is only 1.6 times 10 to minus 19. Okay, so this is 1.57 Tesla. Okay, for part B, what is the resulting kinetic energy of the deuteron? Okay, so first of all, we can find V equals R QB over M, okay, which is something like R equals MV over QB, and then we move the term other than V to one side, and then so we can get the expression of V. So here it is actually 0.53, the radius, times Q is 1.6 times 10 to minus 19, and then times B. B is this stuff what we calculate just now, 1.57, and then over 3.34 times 10 to negative 27. So the velocity is actually 3.99 times 10 to the 7 power meter per second. Okay, so it's more than 1/10 of the speed of light. Okay, 就是超过光速的1/10。所以原则上要用那个狭义相对论，但是这里还没有叫狭义相对论嘛，所以我们还是用 classical 的那个 kinetic energy， 叫做 1/2 mv square。如果是狭义相对论的话 ，k 是等于这个伽马减1，然后 mc 平方这样的。那这个伽马是等于1除以1除以1减掉 v 除以 c 的平方，这样就是这个。那如果速度很低的话，这个跟1/2 mv 平方是差不多，不过这个是考虑了这个狭义相对论。Okay, so actually this one is like 1/2 m is 3.34 times 10 to negative 27 times 3.99 times 10 to the 7th power, and then quantity square. So this is 2.7 times 10 to negative 12 joule. And then if you just convert this one into EV, okay, so it will be 17 mega EV. Okay, you can just divide this one by 1.6 times 10 to minus 19. Okay, so it becomes EV. Okay, so 17 mega EV, which is smaller than 50 mega EV. Okay, so any questions? Okay, so this part is about the magnetic force on a current carrying wire. Okay, so I would say this is another form of the Lorentz force. Okay, another form of a Lorentz force. So here it says a straight wire carrying a current I in a uniform magnetic field experiences a sideways force FB. Okay, it still use the term FB, but it equals to IL cross B. IL cross B. Okay, so actually we can slightly recall FB equals Q V cross B. Okay, so I will actually show you why it will be like that. Okay, but actually here we've tried to see what it means first. Okay, so first of all, on the left on the left figure, you can see we try to fix this wire. Okay, here and here, and then if we apply a B field, the B field is actually pointing out of the page, and for the first case, we don't have any current. In this case, it neglecting the gravity. Okay, this wire will be a straight wire. Okay, if you just fix it properly. Okay, this wire will be straight. Okay, so the next case is if we have a current going upward. If we have a current going upward, then the wire will bend to the right side. And for the third case, if the current is pointing downward, the wire will bend to the left side. Okay, so actually we can simply use this one to see what it means. Okay, so actually we have I. Okay, so and then we have L cross B. So what is L? L is actually the length. L is actually the length of the wire. And L is a vector, so what is direction? So the direction of L follows the direction of a current. So which means that, for example, this point, we will consider the L is pointing upward. Just follow the direction of a current. And then for the B is pointing out of the page. So we use right hand rule, your forefinger pointing upward, and then you cross it out of the page. Your thumb is pointing to the right side. So it just so we have FB pointing to the right side. Okay, for the figure C, okay, I is pointing downward. So in this case, L is also pointing downward. Okay, so L cross B, L is pointing downward and then crossing out of the page. Your thumb is pointing to the left side. Okay, so you have FB pointing to the left side. So all the way matches what it mentioned here. Okay, just now I mentioned that this is another form of the Lorentz force. So actually, this is something like Q times V cross B. Q times V cross B. Okay, so actually you can regard it something like this. So you can simply consider it is like a DQ and DFB, something like this. And then you can consider we have a DQ over DT. And then we have this V times DT, and then cross with B. In such a way, DQ dt is actually I. And V cross dt, you can consider it is the length of the wire. Okay, this is the velocity of the charge, and then times the time. Okay, so it's a length. Okay, so you can consider it's the length of the wire, and then cross with the B field. Okay, so this is pretty much the Lorentz force. Okay, so I would say this is another form of the Lorentz force. Okay, so in this case, in this formula, you can just consider if a wire is not straight, or if a B field is not uniform, then you can just separate the wire into many small segments, and then you apply DFB equals I DL cross B for each segment, and then finally you add all these FB together so that it is the total force acting on the wire. Okay, so if a wire is not straight or the field is not uniform, then we can just use this procedure. So simply like how we find the E field for a continuous charge distribution. Okay, so here we have a sample problem. So it says a straight horizontal length of copper wire has a current I through it. What are the magnitude and direction of the minimum B field need to suspend the wire, that is to balance the gravitational force on it? The linear density of the wire is this one. Okay, so actually this is the wire, and then of course the current is going out of the page. Okay, just follow the direction of L, and then we have a gravitational force mg pointing downward. Okay, so it asks you to have FB to cancel this mg, so which means that if we have a mg equals this FB is IL cross B, and then suppose L and B are perpendicular to each other. So yeah, so it is nothing but I times L times B. Okay, so here we should have B equals mg over IL. Okay, so it asks you what is the minimum B field. Need to suspend the wire. So actually we can just plug in all the number. 46.6 gram. Okay, gram is not a SI unit, kilogram is an SI unit. So it is actually 46.6 times 10 to minus third power, and then times G is 9.8, and then over I is 28 times L. What is L? L is an sorry, it should be something like this. M over L times G over I, something like this, and then going back to here. Okay, we don't have the L. This 46.6 gram per meter is the linear density, mass per unit length. Okay, so it should be M over L to be this value. Okay, so in this case, B is 1.6 times 10 to minus 2 Tesla. Okay, so it is simply like that. Okay, so let me simply talk about this talk on the current loop, and then we can finish. So here it means that if we have a current carrying wire in the B field, then there will be a torque making this loop to rotate. So the idea is like this: if the B field is pointing to the right side, and suppose there is a current I going out of the page here and then going into the page there. So we have a L cross B. L is pointing out of the page and then cross to B to the right side. So your thumb is pointing up. So you have a force pointing upward. And then for this one, L is pointing into the page and then B is pointing to the right side. Okay, and then in that case, so you use your forefinger pointing into the page and then cross to the right side, your thumb is pointing downward. So you have F3 pointing downward. And F2, F4 will be 0. Yeah, because the B field and the current are parallel to each other. So we only have F1 and F3. This F1 and F3 will make the loop have a torque rotating clockwise. And this torque will be nothing but tau equals N. N is the number of turn. N is the number of turn in the coil. And then times the I times the current times the cross-section area. This is the cross-section area. And then times the B field times the sine of theta. So it will be vary from 0 to 2 pi. Okay, when the loop is rotating. Okay, so this theta actually varies. Okay, so yeah, so it's roughly like that. And that will be okay. The tau equals mu cross B. Okay, so this thing you can separate into this part NIA. We can define it to be the magnetic dipole moment. Magnetic dipole moment. We denote it as mu equals N times I times A. N times I times A, and then cross with B. Okay, so it turns out to be this tau equals mu cross B. And how to define the direction of this A? Okay, it actually follows the current and using the right hand rule. Okay, we try to use our finger follow the direction of the current. Something like this. Okay, it is rotating something like this, and then you use your finger follow this direction, and then your thumb will be pointing this side. Okay, So I try to do it like here. This current is something like this. You use your finger follow the direction of the current, and then your thumb will be follow the direction of the A. So which means that the A is pointing to this direction. Right, okay. Okay, so